Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. So in this video, we still continue about the measures of allocation for ungrouped data, which in this video we discuss about the question and example regarding that ungrouped data for measures of allocation. So first example 4, find the mean of a set of numbers. So here's the set of numbers. So to find the mean, we just sum all of this and divide by the total number of data. So here total number n is 7. So divide by 7, then we get the mean is 5.57. Okay, very straightforward. Right, next for question B. So here we have a table. So in order to solve this, first we have to total out all this frequency here to get the total number of n. So here we total out and we get 20 here. And then to find the mean, we still have to use this formula. And since here we have frequency and the number of children, so we'll multiply each one. So 0 multiplied by 2 plus 0 multiplied by 5 plus 2 multiplied by 7 plus 3 multiplied by 3 and so on until 5 multiplied with 1. Okay, over here. And then we divide with 20. Right? So press your calculator and you get the answer 2.05, the median. Sorry, the mean. S bar is for mean. Right. So next, example 5. Find the mode for the following set of data. So look at the data. How many data that occurs most? So as you can see here, 5 we have 2, 1, 2. And then 5 we have 3 times. 1, 2, 3. And 3 we only have 2. So the most occur data here is 5. So the mode should be 5. Right? And then next for question B. So we have 2, 3, 5, 8, 10. So how many that occurs most? So 2 only once, 3 also once, 5 only once also, 8 and 10 also only once. So obviously there is no mode for question B. And then next for question C. So look at here, 0.4. So 0.4 we have 3 times. And then 0.7 also 3 times. So we have 2 sets of data that occurs the most. So since we have 2, that's 0.2 and 0.7. So our answer would be 2 also. That is 0.4 and 0.7 as our mode. Okay? Clear? Good. So next we move to the example 6. So now we dealing with the median. So remember, median is the middle value. So in order to solve this one, so check the number here. Is it arranged or not? So as you can see here, the number is already arranged. So we just determine the middle value. So 1, 2, 3, 4, 5, 6, 7. So the fourth one will be the middle value, right? So our middle is located here. That is 201. Right? Right. Next for question B. So check also here. Is it the number arranged or not? So as you can see here, the number is not arranged yet. So before we determine the middle, you have to arrange first. So here we already arranged. So the smallest one 70 and the highest one would be 36. And then count the number of data here. 1, 2, 3, 4, 5, 6, 7. So the middle value should be here, right? 24. So our median here is 24. Okay, very simple. Because the number of data is odd, so the middle value should be in the middle. Alright, next for question C. So again, for this question, the number is not arranged. So before we can solve, we need to arrange first. So we arrange. So 2.71 the smallest and 8.61 is the biggest. And then count the number of data here, 1, 2, 3, 4, 5, 6. So we have even number. So for the even number, the middle would be the middle here. That is, we have to find out the average for the two middle values. So here we find the average of these two middle value. So 4.35 plus 5.48 over 2. So we got the median is 4.915. Okay. Right, next for example 7. So now in this example, we combine together mean, mode, and median. So here is the set number of data. So we have two unknown here, that is x and y. So given the mode is 6 and the median is 7. So we have two questions here. The first one, find the values of x and y. So after we obtain this value, then calculate the mean of the data. So we solve the first question first, that is to find out the value of x and y. So first look at the mode. So given mode is 6. So here 6, 1, 2, 11 also 2. So x must be 6, right? In order to make the mode is 6. Okay. So as you can see here, I write down 11 occur 2 times, 6 also occur 2 times. So in order to make the mode is 6, so the x value should be 6. Okay. Alright, next, after we determine the value of x would be 6, and find the median if find the y if the median is 7. So after we find out x, you have to arrange, okay, in ascending order. So we put y right after 6, okay, because it stated that the median is 7. So here look at the total, the number of n here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10, the median should be in the middle here, that is 7. So y should be right after 6. Because we want to find out the median, you have to find the average of the two middle values, right? So the average of two middle value, that is 6 plus y over 2 equals to the value of median, that is 7. So with that, we can find out the value of y. So the value of y would be 8. Okay. So we already settled the first part of the question, that is the value of x is 6 and value of y is 8. So after this, using this value, we find out the mean. So again, we use the arranged number here, and then we substitute y with 8. So here what we do, already substitute y here with 8. So sum of this and divide the number of data, that is 10. So just press your calculator and then you'll find out the value of mean is 7.8. Or you can also give in the fraction, that is 39.5. Right. So now we move to the example 8. So in this question, find the first, second, and third quartile of the following data. So here is the following data. And as you can see here, the data is not arranged. So you have to arrange the data first. Then the median would be the middle value, right? 1, 2, 3, 4, 5, 6, 7. So the median one would be the 4 observation here. So the median straight away we know it is 5. Then for the first and third quartile, we cannot use the same concept as median, right? You have to use the formula nk over 4 first to find out s. So we use the formula s to find out s first, that is nk over 4. So n is 7, the number of data is 7. And then k would be the first quartile, so k is 1 over 4. So we find out that the value of s is 1.75. So if you refers to the note, 1.75 is a non-integer. So since 1.75 is non-integer, so to determine which observation, so we will choose the next observation. So next after 1.75 would be the second observation. So from the second observation, 1, 2, so this is the second observation. So our first quartile would be 4. Okay. So let's try for third quartile. So for third quartile, this time nk over 4 and same, n same, yes, there is 7. And k here is a third quartile, so k would be 3 over 4. So then calculate, then we get 5.25. So 5.25, like 1.75, also a non-integer. So again, since it is non-integer, so to determine the third quartile, we will choose the next observation. So after, not the nearest, the next observation. Because as you can see, the nearest is 5, right? However, we need to choose the next observation. So after 5.25 would be 6th observation. So we choose the 6th observation. So look at the set of data here. 1, 2, 3, 4, 5, 6. So the 6th observation here is 8. So our third quartile would be 8. So this is correction here, not the first but third quartile. Okay, third quartile. 8. Right, so next for question B. So for question B, again the data is not arranged. So you have to arrange first. So here is after we arrange. And to make easier, I already put the order of the observation here. So from the first to the 12th, the last observation here. Okay, first we find the second quartile, okay? Because the second quartile would be the median. So the median, so since the number of data here is even, so the median will be in between 5 and 6, right? So since in between 5 and 6, that is the 6 and 7 observation. So to find the median, we will find the average of between 5 and 6. So we got the value of the second quartile, which is also a median. It's 5.5. Okay, so that's for median. And remember, this step only for median. For other quartile, you have to use formula nk over 4 first, okay? So for the first quartile, first we find the S, that is formula nk over 4. So here n is 12. The first quartile, so k would be 1 over 4. Then we got the value of S would be 3. So here 3 is a integer. So since it is an integer, so remember, refer to the notes. If the number is integer, so in order to determine the value of the first quartile, we have to find out the average of the third and fourth. Okay, third. So we average third and fourth. So here third and fourth, which is 2 and 3. So we will find the average 2 plus 3 over 2. So the value of our first quartile would be 2.5. Okay, let's try again. This time for the third quartile. So for the third quartile, now the value of k is 3. N is same, right? That is 12. So this time the value of S would be 9. And similar to the first quartile, 9 also is an integer. So since it also is an integer, how do you find out the third quartile? Remember, we previously, since it is 3, you have to average between 3 and 4. So now, if it is 9, would be, yes, the average of the 9 and 10 observation. Okay? So 9 and 10 observation, so refers to the data above. So 9 and 10 observation will be 7 and 8. So we find average of 7 and between 7 and 8. So we got the value of the third quartile would be 7.5. Okay, so that's how we find out the first and third quartile for this example. So now we try to use the same concept, but now for the percentile. Remember, the percentile and quartile, we will use the same formula, except to find out S, instead of nk over 4, now we'll use nk over 100. Right. So before we can proceed with the find out the values of percentile, since the data is not arranged, so we have to arrange first. So we arrange all the data, and then to make easy also we put the observation, the number observation. Okay, and then we can proceed with the 15 percentile first. So 50 percentile, so remember we use the formula nk over 100. N is 12, N is 12, K is the question 15, so K is 15, so substitute, and 12, K 15. So we find out the value of S would be 1.8. So 1.8 is a non-integer, okay? So since 1.8 is not integer, how to find out the percentile? Remember the quartile? What we use? Yes, we use the next observation. So after 1.8, it will be the second observation. So the second observation here is 2. So the value of the 15 percentile would be 2. Okay. Right. So next for the 25th percentile. So for the 25th percentile, so nk over 100. So now k would be 25. So after we calculate, we find out the value of S would be 3. So 3 here is an integer. So remember what we need to do if it is integer? Yes, we find the average for this 3 and the following, that is the fourth integer and the fourth observation. So here the third is 2 and then the fourth observation is 3. So we have found out average between 2 and 3. So P25 will be average between 2 and 3. So we got the value is 2.5, okay, for the 25th percentile. Okay, lastly, for the 60 percentile, so now the value of k will be 60. So substitute into the formula, then find out the value of S would be 7.2. So 7.2 is non-integer. So non-integer, we use the same concept as the 15 percentile. That is, we will choose the next observation. So after 7.2 would be the 8th observation. So look at the arranged data here. So the 8th observation here would be 6. So our 60 percentile would be 6. Right. Right. So that's all about the example regarding measures of location for ungrouped data. So please try to solve the exercise to make sure you understand how we find out these quantities. So thanks for watching, and don't forget, in our next video we will discuss about the measures of location for the group data. So until then, thank you very much. Bye bye.